Evaluating RAG systems is hard, like really hard. In this video, we're going to be talking about a way where you can compare this RAG system versus that RAG system in a standardized way so that you can be confident that this RAG system is the right one for your use case. It's visual, it's easy, and we're going to be talking about it in this episode of RAG Masters.
Hello, everybody. Welcome to another episode of RAG Masters, a show about, yes, retrieval augmented generation. Maybe not everyone's favorite topic, but our favorite topic on this show. I'm Neil Katz, longtime tech entrepreneur. With me today is, of course, Daniel Warfield, my co-pilot in this experience, a RAG engineer, a data scientist, and a phenomenal educator on all things retrieval augmented generation. Daniel, how you doing?
I'm doing great. And we're going to be talking about a topic that's very close to my heart because LLM testing and testing around RAG and other LLM related things is, I think, tragically under-discussed, but incredibly important.
I completely agree. I mean, at our company, iLevel, we build RAG all day long. And I'll be honest with you, there's no silver bullet. Evaluating RAG pipelines is really, really hard. And a lot of the technologies out there to do it, we talk to these companies all day long, are just actually don't really solve the problem of how to evaluate the pipeline. There's a couple of different problems in it. We're going to talk about one today that I think is crucial, which is almost completely forgotten in the evaluating process because it almost seems so simple, but it's hard. And this is, how do you generate question-answer pairs, which can be the ground truth for your RAG evaluation? And that seems simple, like, hey, I've got some documents, I can make up questions and I can make up answers. But can you? I mean, think about it. If you have thousands of pages or millions of pages of documents, can you generate thousands of questions? How long will that take you? Can you write perfect answers? How long will that take you? Are you a subject matter expert? It's actually pretty hard and pretty time consuming. And we find actually sometimes building a great RAG system is faster than testing it. And this is one of those roadblocks. So I am super excited today because actually you pioneered something really, really interesting, a really, I think, novel approach. You're going to walk us through it today. Heavily automated, but a little human in the loop in exactly the right place. So you get really high quality QA pairs. You can do ground truth and really eval really, really well. All right. That's the wind up. Let's see the pitch.
Yeah. So, all right, we got slides as always. So today we're going to be doing LLM as a judge, right? So the idea is we're going to be using an LLM to say if a RAG system is performing well or not. That's the whole idea. Mm-hmm. So the best way to do that, there are actually a lot of ways you can do LLM as a judge, but the best way to do that is you have your question and then you have a true answer to that question. So for instance, what is the title of this document? And you say the true answer is A Cat in Time, for instance. And then you have a RAG system try to answer that same question. And then you have an LLM look at the question, the RAG system's answer, and then the true answer. And then the LLM says, hey, is this correct or incorrect? Now, this system is not perfect, but it's probably one of the best ones in quickly and expeditiously evaluating a RAG system.
Yeah, it makes a lot of sense. And people call that QA pair, they call that ground truth. Like a question you know is a sensible question and an answer you know is correct. Now you can compare your RAG answer to the ground truth that you've created prior.
Exactly. So if we're actually going to build this up, we don't need one question and answer, right? If we're trying to evaluate a RAG system and maybe compare RAG systems, you probably want a selection of question answer pairs. And then downstream, what you end up doing is you put your RAG system through all the questions and you generate a bunch of RAG answers. Then you have an LLM judge all of these questions, answers, and RAG answers to create a general judgment. So that's basically what we just discussed, but now you're doing it tabularly, so across all of these rows, right? Yeah. So then kind of the distillation of all this is the LLM can give you an idea of the performance of a RAG system. And if you have the same LLM judge with the same QA pairs, comparing two different RAG system answers, one might be 80% correct, one might be 90% correct, you can be more confident that in this case, RAG system 2 would be more performant in this use case with these types of questions than RAG system 1.
Yeah, it makes a lot of sense to me. And look, there's a lot of commercial software out there now. There's some open source software that does this LLM as a judge process or pipeline, but they're all missing one key step. which we're going to talk about today. How do you generate the ground truth? How do you generate the question answer pairs
Yeah.
that LLM as a judge needs to actually do the evaluation?
Yeah. And like, by the way, we're not even going to get into it because it's actually trivially easy to do the LLM as a judge. So as Neil is kind of alluding to, like actually whipping up the LLM as a judge, like you can just pause and read through this. Super straightforward. But the issue is actually generating.
We're going to give that code out, right? We're going to have the code available, I assume. So you don't even have to pause the video. You can literally just take it.
Yeah, exactly. But yeah, actually generating these question answer pairs, as Neil's been saying, is hard. So like, let's get into why, right? So we do this. Like Neil and I both have a dog in this race. We both have some scar tissue in this.
Painful.
We spend hours and hours and hours, weeks and weeks. We spend a ludicrous amount of time looking at documents, trying to understand them and say, this is a good question and this is a good answer. This is a good question. This is a good answer. And when you're doing one document, it's not that hard, right? You look at this document, you can probably think of a few questions you can ask a RAG system and then a few answers for those questions. But think about if you have a lot of documents, if you have thousands of documents.
And complex documents, and that you may not even understand them when you start. Like you may not be a subject matter expert. So like you have to really study, and that's time consuming. You're taking tests basically.
Yeah, like there's a classic anecdote where like a Lyft engineer talked about how he became an expert on Swedish street signs accidentally, like one of the ones who knew the most about it out of anyone in the world because he just spent so long as a data scientist just needing to understand. It's hard. Like the practice of this type of stuff is really difficult. So if we can speed this up in any way, if we can make this faster, that's the goal. And that's really what we're talking about.
Yeah, this is saving our own lives, and hopefully you guys benefit from it, basically. We built this for ourselves, so but I think it's really useful for everybody.
Yeah. So let me share my screen real quick. Sorry, it's supposed to be up. Can you see my screen?
I can see your screen.
Fantastic. So essentially what we have here is a way to automate this process. So instead of needing to read through a document, here what you're looking at is the document up top. And then instead of just like needing to read through the document, manually define a question and answer pair, blah, 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 et cetera, what we've done is we've used our parsing system to parse through this document and understand this document. And then we're generating question and answer pairs automatically with an LLM that is, relevant to this information, right? So here the parser, we're looking at this specific flow chart. And we're saying, what is the initial step in the SIOC packaging process? And the initial step is determining if the item is new or existing, which is true. Like that's essentially the first step of this system. So instead of needing to spend the physical time of understanding this, typing it, we can quickly reference this and then say, is this a good question or not? So here we can accept it.
So right? I want to maybe just rephrase that a little bit and slow it down so folks know what we're looking at here. So, this is your system essentially is reading the documents in the RAG system. Mm-hmm. It's pulling out pages. This happens to be a single page in this Walmart supply chain document that we use as a test document often. The system is pulling out a page, and then it finds finds an object on that page, often a complex one like a table or a diagram, but sometimes a text block. It highlights that object for you here in pink, so you know exactly what object is being tested. Then it provides a rationale for why it's important to test this particular object on the page and what kind of questions you might want to ask about it. It then generates a question, generates an answer, and then you as the user can just very simply go, yes or no. Yes, this is a good QA pair. No, it's not. If it's not, you skip it. If it's great, you accept it. And so the human in the loop in this case, instead of days of like reading these documents, generating questions, writing answers, trying to figure out if they're correct, trying to write down what page, where this question answer pair came from, where's the ground truth from in the documents. Now it's just like, yes, no, yes, no. So to me, it takes I don't know how long it takes to generate a really good question answer pair. I mean, it might be 5 to 10 minutes. This is now 5 to 10 seconds.
Exactly.
That's a big deal to me.
It is a big deal. It's a huge deal. And it's it's kind of hard to understate unless you've gone through. It's a simple statement, right? You can do question answer pairs faster. It's really like it's kind of like saying if you got your leg chopped off, we now invented a way to grow it back. Like if you've never if you don't have an idea of how painful it is, then it might not sell. But like it's kind of a simple statement. Like generating these question answer pairs, like we've literally spent months doing it. And if you're working in an NLP related industry around documents, you understand how painful this is. So now you can just kind of flip through and generate these significantly faster.
Yeah, I love that. And I love it's a tool that, you don't have to be an engineer to use. So you could hand this to a subject matter expert or even someone who's maybe not a pure SME, but understands what's going on, and they can just, a non-technical person, importantly, go yes, no, yes, no, yes, no, yes, no, generate hundreds or thousands of these question answer pairs, which then can go into a RAG eval system. So I'm loving it.
Yeah, and it's also, I think if we flip through some of these, right?
Let's look at some. Yeah, let's stop talking. Let's show. Let's see what.
Yeah, okay. So, what does the flowchart ask after determining if an item is new or existing? The flowchart asks if the item is required to be SIOC shipping
Required.
owner. Yeah, I see. I don't know. I don't have to know this. I just said SIOC, and I'm like, yeah, sure. And the reason it's choosing to come up with this question answer is because, so this whole thing is essentially a chain of thought prompt where I'm telling it to think of a rationale, and I'm telling it you're building question answer pairs for information extraction. So I want you to think of problems an information extraction system might have, and I want you to generate question answer pairs that would test that. And here it's saying an information extraction system may struggle with recognizing the flow and dependencies between elements. So it's looking at this item. It's saying, yeah, we need to understand this flow. And then it's asking a question that has to do with several of these items and how they connect with each other.
Yep. And it's doing that partially because of, our API, our GroundX APIs underneath the covers here, which are able to ingest complex documents, understand where's the table, where's the form, where's the graphic, turn it into LLM ready data, and also provide the coordinates for those objects on the page, which makes rendering this visually a whole lot easier.
Yeah, and the rendering of the page is also kind of another experience thing. If you've never done LLM evaluation, you might not really realize or think that this bounding box is super important. But if you have 100 questions across 100 different documents, for instance, and you just have a question answer in a document, then if there's something messes up with the system and you want to get an idea of why it's messing up, so you want to dig through the document and find the answer, it can take, oh my God, I've probably spent 20 minutes on a single question out of a set of 1,000 questions. It's ridiculous. So being able to quickly identify stuff, you don't really need this from the LLM as a judge perspective. But when you're practically using LLM as a judge and iterating on that, as a general process, having the ability to quickly identify this is the page, and not only this is the page, this is the bounding box, so you can quickly see where information is coming from. I can't even describe how valuable it is.
You're totally right. LLM judge is cool, but when the answer is wrong, why is it wrong? Well, you have to go investigate. Where's the original information this came from? Let's go compare the original page versus the QA pair versus the answer that we provided. What are we looking at? Maybe it's a weird flowchart like we just saw. Those are hard for RAG systems to figure out. Let's go and now you gotta diagnose the problem. You can only do that if you actually know where the QA pair comes from. And this does that really instantly.
Yeah. Also, I think another benefit of this is that it's not a human. When you're generating question answer pairs, you get tired and you start being you start realizing the types of entities that are easier to make question answer pairs about and the types of entities that are harder. Here, we're just iterating through.
Yeah, let's see a few more.
Yeah, we're iterating through chunks essentially. So what eye level is identifying, or what X-ray is identifying as key elements within pages, we're iterating through them, and then we're generating question answer pairs on an element by element basis. So that means practically if you're a human and you see this page and you're okay, I need to generate 3 question answer pairs, let me just generate them based on this flowchart. And then you generate 3 and then you move on. But here there's also all of these elements up here. So now we have this one chunk that's saying, What is the weight limit for cases under Walmart's packaging requirements? And it's 30 pounds, which is, somewhere up here in this text. You still have to do a little bit of reading. And if I didn't want to read this, I could be like, screw that. I can't immediately find the answer. Let me choose another one.
So you have some other pages here, other stuff that we could see?
Yeah. So if I skip,
jump to like another bit, how we're doing it.
If I skip a few batches, I think there's a limit of the number of batches per page. So yeah, okay, cool. So now here's a completely different page. And then, so here's a example of why it's useful to have a human in the loop. Yep. So I think I've seen this example before when I've been testing this, and I think there's really two ways you can approach it. You could attempt to have the QA generation for like the actual prompting for the model that it generates the QA pair. You can attempt to really describe, hey, it only knows the information in this in the question. So if you ask a blanket question like, what is the title of this figure? It doesn't know it's supposed to be looking at this point. That's the whole point of testing a RAG system, is it has to look at a billion documents. So if you say, what is the title of this figure? You have to qualify what this figure is. So this would be an example of the QA generation system maybe not making a good answer. I think there are...
Actually, I think it's not different. I think it's not a good question, is what I would say.
Oh, yeah, sorry. It's not a good question.
It's really asking, like, no one would ask this question, like, what is the name of an object on page 42 of a document I don't know about?
Yeah.
So, like, literally, the LLM was like, from a literal perspective, yeah, this makes sense as a question. But as a human, this is not a real question a human would ask. And you go, skip.
Exactly. And you could modify this approach, right? Like, so this is a notebook and we're going to share the code. So you'll just be able to get rocking and rolling, which is great. But you could also add on this, right? So you could add the ability to have someone quickly edit the question, or you could have basically several options for re-rolling. Like you could have buttons that say, make it more contextually relevant, or, just try again or something.
Like a re-roll kind of thing. Yeah.
Exactly. So like by having this human in the loop, you can think of this as like a packaged approach, but really I think of this as a core process, right? You have QA generation, and then you have human in the loop, and then how the human is interacting with those QA pairs, you could really experiment with, which I think is really compelling.
Yeah, totally.
So I think we kind of get the idea, right? So this one's kind of cool. I think I've seen this before. What does the B case pack configuration contain? So this chunk has, it's relating the B and the C. So if we go to like a different question.
Yeah, again, kind of a weird phrasing. I mean, it's good to show that you can pull up that information, but no one would probably ask it that way. The human would probably say, if I package something for the warehouse, what do I need to do?
Yeah, they might ask this question. I was trying to get to this one. So how does the C case pack differ from the B case pack in terms of warehouse packs? So someone might phrase this differently. So you could rephrase it. But I do think this is something a human might ask, right? Like I know, like I just got trained. I know there's the B case and the C case, but like what's the difference? So the ability to automatically identify that information and then construct a QA pair around it, super cool. I will also say, like, it is definitely more useful to bias your question answer pairs based on what a human would ask. But I do think it's also useful to have just information extraction questions, right? Like
that can just prove the viability of the system for sure.
Yeah. So there's all sorts of use cases. I think we get the idea. I think maybe I go briefly into
see what's going on.
Yeah, like how it works. Let's do it.
Yeah.
So okay. So let's see. Let's go up to the top. So I have this notebook that basically does everything. So the first step is really GroundX. So if we can go to my the slides, the Google Sheet slides.
And for those who don't know yet, GroundX are from my level, our company, but GroundX are essentially APIs for enterprise grade RAG that consist of GroundX ingest, where you ingest your documents, we process them, turn them into LLM ready data. And then GroundX search, where you do the RAG search. It's like a hybrid search. But the important thing here is the GroundX ingest, I think, at the moment is what you're dealing with, right?
Yeah. So we have this system where you upload a PDF and it automatically identifies elements in the PDF and it breaks them down into LLM ready data. And we do that representation in a variety of ways. We do it in like JSON, we do it textually. And then if there's tabular data, that gets broken down into JSON. So it depends on the actual items that exist in the page.
Yeah.
But we're turning it into LLM ready data. So then you can think of really a document as, and we call that LLM ready data semantic objects. You can think of a
Most
document
people
as
call
a,
them chunks, but they're like super chunks. They have like a bunch of metadata around them, so we
yeah,
call them semantic objects. But most of the
yeah,
RAG universe says chunks.
yeah. So you can, so from our universe, when you upload a document, you can think of a document after it gets ingested as a big list of these semantic objects that have broken down information in documents into LLM ready data. And normally we would just store those semantic objects for retrieval augmented generation, because you can do RAG based off this as well. But here what I'm doing is I'm not really doing retrieval augmented generation. I'm doing like parse augmented generation. So I'm skipping the whole storage and search aspect, and I'm just iterating through all of these parsed elements and generating QA pairs. And in the UI from before, you saw that there were this concept of batches and questions. What I'm doing is I'm zooming in on a specific item that our ingest pipeline extracted as a semantic object. And then
Okay.
I'm using that as an augmentation to generate a list of 5 question answer pairs. Then
Okay.
you're just going through those 5 question answer pairs for the specific object. Then once that's done, you move to the next one. Once that's done, you
So the
move to the
batch
next
is
one.
not at the page level. The batch is at the object or the chunk level on the page.
Yeah, and what's kind of cool about it is you can kind of configure, right? So I have some filtrations for ease of use. I'm only using chunks that or semantic objects, chunks, same kind of idea,
Yeah.
that exist on one page. And that was just an arbitrary distinction, so that's easy for me, for my eyes to quickly
Sure.
find the answers to stuff. If you decided you wanted to test that, you could do semantic objects that exist across multiple pages, because our semantic objects can do that.
Yeah.
So you can kind of do pre-filtering to kind of configure what types of questions you want. Maybe you don't care about text. Maybe you're only worried about figures. You could filter all of the semantic objects for figures or for tables
Sure,
or whatever. So you have like this pre-configuration step where you can filter based on like the types of information you want to generate question answers based off of. And then you generate the question answer pairs, and then you can do prompting to change how those get generated and what they prioritize. And then you end up with like a big list of these semantic object question answer pair things that you can then evaluate and then potentially edit as a human being.
That's smart. So if I know my RAG pipeline is struggling with certain kinds of financial tables, you can zero in on those tables and say, let's only create QA pairs around those and test around that.
Yeah. And yeah, I hadn't really thought about it, but your filtration step could include an LLM, right? So you could ingest the semantic object, and instead of generating question answer pairs, you could say, I only care about these ones. Is this semantic object, does it contain the type of information that I care about or not? So you could use an LLM to do very complex filtering based on the content of the semantic object, which would also be super cool.
All right, let's go back under the covers here and show people how to build this thing.
Yeah. So I think I'm still sharing my screen. Can you see this?
We can see the document understanding slide.
So not the document understanding slide.
Oh, you want to go back and share your?
Yeah. Sorry, we're bouncing around here. So I uploaded this one document, and here what I'm basically doing is I'm saying that this is the document that I uploaded to GroundX, and I'll document this code a little bit, and we'll be sharing the code. So I'm going to be kind of going through it from a really high level, and if you're interested, you can kind of dig in. But basically, we uploaded a document which has been parsed by X-ray. So we have this X-ray data, which is a breakdown of basically a list of all of these semantic objects. I have some, kind of quality of life stuff for rendering. But here we're kind of getting the meat of it, the question answer pair generation. So here I'm using OpenAI's structured output. I believe, it's called response formatting. So I'm defining a pydantic object that has first the rationale, then a list of 5 question answer pairs. And I'm breaking it out like this in this very not programmatic way so that it's easy for the language model to easily generate these question answer pairs without hallucinating or making some mistake based on formatting. So the reason we do the rationale first is because I don't want it to make high level, stupid, like not very useful questions. I want it to think about what is the problem with this type of information. Here I'm saying, look at the data and construct a rationale. This rationale should include a breakdown of the types of information presented and what an information extraction system might fail at when analyzing this type of data. So it thinks of that rationale before it generates the question answer pairs, which helps to make the question answer pairs more robust to the actual semantic object that we're analyzing.
This here could be, I think, easily modified. Once you grab our code, easily modified for your use case. If you're focusing in on healthcare or finance or some domain, you might want to change this prompt to more focus the model on the kind of questions it will ask. But it's pretty easy to do that, right?
Yeah, absolutely. You literally just change this text, and you can also change the model. You can also change the temperature, so you can get a more variety if you wanted. It's totally up to you. Kind of the world's your oyster. But yeah, so then our semantic objects, one of the things that we do is after we look at your document, we basically create a summary of like the JSON representation, the textual representation, some of the contextualization around like the relevant pages that it's near. And then we create this thing called the suggested text that represents the semantic object that we're dealing with. And that's just a big block of text. So what we can do is we can say, hey, I want you to generate these question answer pairs, use this suggested text, which is just, this is the context, and then we use the suggested text, and then that gets stuck in there. So we have basically a summarization from our parsing system, and then we say, hey, we want you to generate a bunch of question answer pairs, and then it just does that. So you have the rationale, and then you have questions and answers. And then I also keep track of other information from our parsing system, like the URL that the document exists in, the page number that we're dealing with, and then the bounding box or bounding boxes that encompass that semantic object.
Yeah, that's also right. The bounding boxes, that would help you do the visualization. So you could actually show on the screen where that object was on the page, right?
Exactly.
That's what that pink box was on top of the flowchart.
Yeah, and here I decided to do semantic objects that exist on one page. So I think filtering, maybe up here or down there, I can't remember. But I filter for semantic objects that only exist on one page, but I do allow for multiple bounding boxes. So like single bounding boxes are like figures or tables. They're often in one bounding box. But if you have textual objects, they often exist within multiple bounding boxes.
Right.
But you can make that decision, right? Like you could filter by semantic objects that just have one bounding box, that have some number, totally the world's your oyster.
Yeah, this is just so people understand. This is something kind of particular to or specific to the way GroundX works. This is not how most RAG systems do anything. So in our GroundX pipeline, when we're ingesting these documents, we're creating literally bounding boxes around every object on a page. Here's the text block, here's the table block, here's the graphical block, here's the flow chart, whatever it is. And then sometimes, to Daniel's point, this really happens with text more than anything else. Text, maybe we might chunk them into kind of take a couple of different blocks on a page that are semantically actually the same thread, but formatted in a weird way on a page because people design things in cool ways. And we turn that into a single, basically, chunk, but it may have different boxes on where they live on the page. Anyway, this is rambling a bit. The long and the short is you get these bounding boxes on the output of the retrieval, of the ingest. So you know where all these objects are, and then if you want to, you can render them like you did, Daniel, in this visual demonstration.
Yeah, and to solidify this, like there's a thread of information between these various different textual elements that are just bouncing around.
Yeah, thank you. To see it, that's better. Thank you.
So then you have multiple bounding boxes, whereas if you are just dealing with this one tiny thing or with this diagram, it might be a single bounding box. And actually, like this is kind of the nitty gritty. Like you'll notice there are actually different opacities, right? So this is kind of translucent, whereas this one's kind of opaque. Like practically, it's really useful to do some engineering around what things look like and how things are formatted and how you're making it fast. Because when you're doing question answer pair generation, the whole idea is speed, right? So being able to play around with how many bounding boxes are you dealing with? Is this too many bounding boxes and someone's just going to get confused, just acts at a certain level? That's a pretty useful general type of filtering if you're trying to go for speed.
Yeah. And look, there's also one other little detail here, which is that this allows you to visually see if the bounding box is wrong. GroundX is really good, but it's not perfect. Nothing's perfect. And so one of the areas of RAG pipeline failure, whether you use our system or not, is that your parser basically did not understand the document correctly and wasn't able to identify this is the table, this is the graphic. I don't know of any other right pipeline where you could even figure that out. Like if that was incorrect at the beginning of the pipeline, how do you know? This visually lets you know really quickly. Like if that box, you want to bring up that Walmart box again, if that box was only around half the flow chart, or you'd go, wait a second, actually the ingest itself, the parse itself didn't work quite right. That's not something you would put into like a LLM, this whole LLM as judge. You wouldn't use it there, but you would write it down and go, wait a second, I know I've got an error on this kind of object on the ingest, which is super, super useful.
Yeah, and I mean, if we want to get even wilder, right? Maybe you have a particular type of document and you're trying to build a system for understanding that document. Maybe you're like a hardcore AI shop and you're dealing with a very specific type of document and you want to start building a data set of bounding boxes. Having an ability to just like throw it through and then get like a beginning data set for you to start playing around also could be super freaking cool. So there's like all sorts of AI applications, I think, behind having a system that builds bounding boxes. That's totally outside like even retrieval necessarily.
Well, anyone who's trained a visual model knows there's a lot of bounding boxes to be dealt with. Millions of boxes, as we did to train the model. Let's go back into the hood, though. Is there more to how to build this application?
Yeah, so we actually we covered like really the core idea. I think there's a few things that I kind of want to go through really quickly because I think they're useful as an idea. If you're at this point in the video, you're probably interested in this idea. So I want to go through a few other like maybe things to consider. But we basically did it, right? So you can imagine we generated all these question answer pairs. You can imagine just doing this code block a few times. You generate a list, and then you could just go through manually if you wanted. You could just edit the text file. But it's useful, I think, to generate a UI around it just to make it more expeditious, right? So, by the way, our bounding boxes assume a DPI of 150. That's kind of like a thing that's, one of those nitty gritty little details. So to get the bounding boxes lined up, you either need to scale the bounding boxes or choose the DPI to be 150 when you're rendering this as an image. Kind of useful. But basically what I decided to do is I take the PDF and I render it as an image, and then I generate the bounding boxes over that image. So this is just one image that's being drawn over, which is super useful. And then we have these images and we have these questions. You could just generate a command line thing if you wanted, maybe in Colab, but I wanted to make it a little more interactive. So I have this big block of code here that is rendering this as HTML objects with some callbacks.
You're flying around. Just find a spot to land and then talk about what you're looking at.
Yeah, there's really no one spot. It's like, so I have this.
Pick a spot, land us somewhere.
All right, gotcha.
Go ahead.
Basically, so we have these question answer pairs and we have these images with bounding boxes established around them. And now basically what I decided to do was and not a lot of people know this, but if you're in Colab specifically, it has pretty robust HTML and JavaScript sort of functionality built in. So I essentially built a variety of callbacks that wrap these question answer pairs around JavaScript and then render HTML. So we render this big HTML block here that allows us to create buttons and render this image, render this text, and then create these buttons. Yeah. And then essentially what ends up happening after that?
So this basically there's some GUI work here that's pretty specific to Colab.
Yeah, it's pretty specific to Colab, but now we're getting to the one thing that I did want to mention, which is that there's parallel processing. So behind the scenes, what's happening is this code that we had from before where we're generating QA pairs, that's generating them in a queue that is a separate process from the UI. The first time I basically blocked this out was a few months ago. And what I did was I synchronously, once you ran out of code or once you ran out of question answer pairs, it would generate new question answer pairs, and then you have to wait. It like really hampers the usability of a system like this.
Yeah.
So having basically two parallel processes, one that does this rendering and another one that's generating these question answer pairs, and have them linked with a queue, I found to be very effective. And we're probably going to be using this tool internally, which I think is a testament to how useful it is. So that's the long and short of the whole thing,
I
right?
have one more question for you. What's the output? What does this spit out at the end? Is it a text file, a CSV file? What do you get that you can then put into an eval system?
Yeah, so it's totally configurable. But at the end of the day, I would be doing this as a pandas data frame, which is essentially a CSV. So when I say accept, it adds this question answer, the page number, and the bounding boxes that's relevant to a row in a CSV. When I click skip, it doesn't do that. When I skip batch, it doesn't do that. And I just keep doing that, and I keep building this big block of QA pairs, and then some life-saving stuff in terms of like the document URL, the page number, and the bounding box, so that later I can do like testing and stuff without ripping my hair out. So it's just a big
Very
table
cool.
that you then can do whatever you want with, including LLM as a judge.
Very, very cool. I love this application, man. We're going to be using this every single day, and we're going to get this code out there, and hopefully everyone else can find it useful. We just want people to make better RAG applications, whether you use our stuff or not. Just make better RAG applications, and let's all like make this whole field more accurate, more stable, more secure, and see a lot more production level projects, not just, cool little tests. So thank you, man. This is a great piece of software. I love it. And I think people are going to love it.
Awesome.
All right, folks. Well, that was a good one today. That's all for today's RAG Masters. As always, like and subscribe. I should say it at the front of the video, but I never do. So like and subscribe, please, if you've made it to the 30th minute of this video. Hope you find this useful. Code will be in the comments, and we'll see you next time on RAG Masters.